Okay, so let's talk about the trends of the periodic table. You need to make sure that you are filling in the notes on the handout that I gave you guys. I believe it's called Periodic Table Trends. Okay, so let's talk about the history of the periodic table. Check that guy out over there. We've got two scientists. I call them the M&Ms. They both have the last names that start with the letter M. So the first guy is this freaky looking guy over here on the right of the screen. This is Dmitri Mendeleev. And what he did was he basically just arranged the elements. He had them on cards, and he arranged them according to their atomic mass. So he just realized, okay, the small ones, I'll start with those first, and then I will just keep increasing them as the atomic mass increases. And what he realized was that certain properties occurred at regular intervals. And basically, that's where we get the word periodic from. Periodic just means that there are repeating patterns. So this is a look at Mendeleev's periodic table. As you can see, that this is not anything like the one that we use today. So some other guy came along and changed it up for us. So here's the next guy, the next M from our M&M. In the early 1900s, his name was Henry Moseley. He looks a little bit nicer there than old Dmitri. And what he did, he worked with Rutherford, who discovered the nucleus of the atom. And he realized, well, if I arrange the atoms by the number of protons, it makes a little bit more sense. And so what he did was he basically is coined with the atomic number. He discovered that. And that is how we arrange the periodic table today. And so after he was done, there's a few more scientists that contributed to the modern periodic table that we know today. What I want you guys to know is that noble gases, which is the far right group, that was added later on, as well as the two rows at the very, very bottom of the periodic table, the lanthanides and the actinides. Those were added on later as well. Okay, so let's talk about trends that we already know about. The most obvious would be that the atomic number, which is number of protons, that increases from left to right, and as you go from top to bottom, it also increases. So we already know that as you go from left to right, the number of protons and the number of electrons, they increase, and they also increase going from top to bottom. And we also know that elements in each group or family, they have similar electron arrangements, which we'll talk about in a lot more detail later. So let's talk about the first periodic trend that we do not know about. So it's called the atomic radii, and radii is just basically the plural form of radius. We don't say we have lots of radiuses, okay? So basically the atomic radii is the distance between the nuclei of identical atoms that are bonded together. So basically just how far apart are the nucleus from each atom when they're bonded together. Now the atomic radii, as you move down a column or a group, it increases, and this makes sense if you think about, okay, well, we're increasing the number of electrons, so therefore we're becoming a bigger atom. But something that we do need to take note of, you would think that as you go from left to right, okay, we're getting more electrons, therefore our atom is going to get bigger. But it actually turns out that as you add on more electrons, you're also adding on more protons, because we want to have the same number, right? So what happens is as we go from left to right, the atomic radii actually decreases, because we're increasing the number of protons, and what those protons are doing is they are pulling those electrons closer into the nucleus. So therefore our atom is not getting bigger, it's actually getting smaller. if you just remember that protons and electrons, they are positive and negatively charged, therefore opposites attract. So those protons and those electrons are actually very attracted to one another, and that's what causes those protons to pull those electrons in, and therefore atomic radii decreases from left to right. So let's look at ionization energy. This is the energy required to remove one electron from a neutral atom. So as you go down a group or a column, it actually decreases. And as you go from left to right on the periodic table, it increases. So what's going on here is that as you move down a group, the electrons added on to those atoms, they are much farther away from the nucleus. Therefore, it's just easier to pull them off. But as you go from left to right, the increasing number of protons, remember I told you in the last slide, they pull those electrons closer. So therefore, as we go from left to right, it's a lot harder to pull those electrons off, and therefore you need more ionization energy in order to pull those electrons away from that atom. So let's look at electronegativity. Now we definitely need to remember this one. This is one of the most important periodic trends. And electronegativity is the ability of an atom to attract electrons. So basically it's an atom's need, its desire for electrons. It wants to get a full outer shell of electrons. And so if you look at the picture there, as you go down a group or a period, or down a group or a family, it decreases. But as you go from left to right, it significantly increases. If you look in the top right hand corner there, that element with the F, that is fluorine. That is actually the most electronegative atom out there. It is so close to getting that full outer shell of electrons, so it is very, very attracted to electrons. Now when we're talking about electronegativity, we do not count the noble gases, that far column on the right, because they are unreactive. We do not consider them to be electronegative at all. They have a full outer shell of electrons already, and therefore they are not electronegative at all. Let's talk about the last one, the ionic radii. Now I don't want you to know, don't want you to worry too much about remembering the trend of this one, but what I want you to know is that an ion is a charged atom. Basically it means that the number of protons and electrons are not the same, and there are two types. Cations are positive, anions are negative. Now metals, which are on the left side of the periodic table, they tend to form cations, positive ions. And as you go from left to right, the ionic radii decreases for cations, and the same thing is true for nonmetals, which tend to form anions, negative ions. As you go left to right, the ionic radii decreases. But for ionic radii, as you go down a group or a column, the ionic radii will increase for the same reasons that atomic radii increases as you go down the periodic table as well. So make sure that you got all of those notes on your periodic table. I will be checking for these when you turn them in.